Hey guys, how you doing? This is the last little bit. So we've gone through a whole bunch of the simple harmonic motion stuff and we should have a fairly good idea of what these various terms mean. Let's just have a quick look back on our syllabus to make sure we've got things covered. So you guys all have the syllabus document. Describe examples of oscillation. Well, that's pretty easy enough. Things that move up and down. And really, to be honest with you, there's one last major point about this. Okay? And the thing about describing oscillations is this. If you have a mean position where x equals 0, the thing does go up and down, but it's important to note that oscillation, simple harmonic motion, means the further away you are, the bigger the force is trying to get you back to where you started. Okay? And then you go up and you're up here, and then you've got a big force acting downwards. So basically the force acting is proportional to the distance from the mean position. Proportional to? Is that the... No, it's not equal to. You know what I mean. Proportional to. Has something to do with that. Okay? And that's really what examples of oscillations means. Okay? So anything that vibrates up and down. Displacement we should be cool with. It's how far away we are from the rest position. Okay? Amplitude is the biggest possible distance from the rest position that we see. Frequency is how many cycles per second. Okay? Cycles per second. Period is how long it takes for one cycle. So seconds, how many seconds it takes, if you like, per cycle. So there's a cycle. So there's a connection between those. F is 1 over period. Cool with that. Period and phase. Now we didn't talk phase difference rather. We didn't talk specifically about that. So let's work out exactly what that means. Now we know how we had our displacement and our velocity graphs, and they were quite similar. This one went like this. This one went like this. Now you'll notice that this part of the graph, okay, is actually very similar to this part of the graph. In fact, if we took this part of the graph and basically moved it this way by this much, okay, 90 degrees if you like, okay, then we would have this shape of graph. So we could say V is out of phase, okay, of the displacement by a quarter of a cycle, this much, okay, quarter cycle. Or if we were using degrees to do that, a quarter of a cycle is 90 degrees. Or we could say it's pi over 2 radians. So that's using this phase concept, okay? If things are in phase, that means one is doing this and the other one is also doing something like that, and we get them in phase. So that's what that term phase means. Great, that's that covered. Define simple harmonic motion and state the defining equation as that. Well, we covered that till we were blue in the face. I'm really hoping that that makes a lot of sense now. The negative sign in the equation, okay, obviously, because if x is down, pulled down to the negative a long way, a will be positive because it wants to force its way upwards, okay? And we've worked out carefully the equation, the connection between omega and period. Solve problems using the defining equation for simple harmonic motion. This is vital because this is basically where you decide if you know what you're talking about or not. So the place to do this basically, guys, is you've been given this set of resources, okay? A set of notes that's been made up to explain this thing's written, and these practice problems. Now you've got to do these practice problems. So let's have a look at what's in here. It's basically a whole set of links, okay, to what you've got to have a go at. So practicing basic equations is here. Find it, doesn't want to open. Don't ask me why. Cheeky bugger. Let's try this one. Hooray, something's happening. Good. Okay, so you get to this place here, okay. Now, simple harmonic motion, we must be in the right place. Thanks to the Department of Physics, University of Guelph. Let's test ourselves on amplitude, period, and frequency. So here's the deal. It gives us a question. Here's a ball moving backwards and forth with simple harmonic motion. Ball A and ball B. And it shows you this thing, okay? And it actually shows it moving. Then it asks you a question. Actually, it doesn't at this stage. It just tells you something. Its position is a function of time. Tells you that. That's very sweet. Thank you very much. Moving along. Which ball has a larger amplitude? Let me guess. Well, I've got a funny feeling it's ball A. So I click on ball A. It says correct. Hurrah! Continue. And you're going to go through this a longer period. Let's see. Which one takes more time to complete one cycle? Well, ball B's bouncing backwards and forwards fast. Looking good to me. No, it's not correct. Oh gosh, what did I do wrong? Longer period. Ah, that's right. Period is the time it takes for one oscillation. This one is taking more time, so it has a longer period. Ah, I understand. Ball A. Hooray! Continue. What's the period of ball B? Now we have seconds we're counting, and we have to think about what does period mean in terms of seconds. So it's your job to keep going with these guys. And once you've kept going through these, you should have shown yourself that you understand what's going on. All these problems should be attempted, and if you have any issues with them, please send me a message. Okay, so that's that part of this syllabus thing. Here we've got some good questions 1 to 5 and question 9. Try them, explore this website, it's brilliant stuff. Here, questions 13.1 and 13.2 and 13.3 are relevant, okay? And kudos to all these guys for setting this stuff up. They're wicked questions and they're really good at testing your understanding. If you want to get a bit hardcore, here's where you go, okay? Just to see what's going on. Now the equations include a phase constant. There's a bit of discussion about that. That's to do with changing the phase like we saw before. So have a go if you like. It'd be great if you can do them. If you can do this, you can basically cover anything in the IB. Right, back to our syllabus. If you can do this, we've solved the problems. And now apply these equations, okay? Now we're pretty good here. We know that the velocity is, okay, we're VO sine omega t. Now remember how we said the amplitude, okay? We can also call it XO. Well, the maximum velocity we can call VO. So if we've got our velocity graph, okay, doing its thing, something like this, okay, this value here is VO. No problem at all. Now this is interesting. We've got V equals VO sine omega t. Hang on a second. Isn't V equals VO cos omega t? How bizarre. Oh, and actually it's got the same thing, V equals, but now it's got VO cos omega t. How can it be two things at the same time? Well, not to fear, okay? All it's saying is velocity could be this, or it could be this. Assume that these, they don't look very the same, do they? Assume that these things are all in phase and stuff. Let me start that again. That was a terrible drawing. Okay, once again. Let's say we had something bouncing up and down. That doesn't want to play. Why? Talk to me, talk to me. Oh, frustration. Okay, V. We drew a graph of the velocity of the thing. Okay, it goes, well, we said it goes like this, right? But really, all we're doing is we're saying we're going to start time as 0 from the position at the maximum velocity, i.e. when it's in the middle of its motion. Now we don't have to start 0 there. We could, if we wanted to, start 0 here. Or we could start looking at it at the bottom, at the maximum velocity, or the minimum velocity, or wherever we like. It doesn't really matter. The thing is still going to be bouncing up and down, right? So all this is trying to tell us is that we can start looking at it at any point, okay? So if we have this is our displacement doing this, velocity is going to be doing something like this, right? And then onwards, etc. We could start looking at it here, or we could start looking at it here, for instance. So if we lift the thing up and let it go so it falls down, we'd be starting our velocity graph here, and it would actually be a negative sign graph. We could put another one here, which is v equals VO, negative VO, sine omega t. It doesn't matter which one, okay? It just depends where we start looking at the system. So for ease of things' sake so far, we've looked at the whole thing like this. And you should be able to keep it like that. Unless it tells you directly, you must start looking at it from a different 0 point. Okay? Cruising along. Oh, we've now got a different velocity value here. Now, this basically involves maths that the higher level guys will see, but mere mortals like us, we don't have to derive this. But you can know another way of showing velocity, okay, is saying it's a positive value or negative value of the angular velocity times the maximum displacement squared minus wherever it is at that moment that we're measuring it squared to the power of 0.5. Now we'll get to that later, why that is the case. It doesn't really matter, but it's basically saying if you wanted to know the velocity at any certain point, a certain point being defined by x, okay, you can do that if you know the maximum displacement. You take the maximum displacement squared from the current position squared, times it to the power of 0.5, multiply it by the angular velocity, and you can find the velocity. Now I believe that's in the formula booklet, so it shouldn't be too much trouble. Okay, and as we just said, we can start it in different positions, so you can say x is a sine wave or a cosine wave. It doesn't change the way the thing moves. That's the important thing. Okay? So we can use any of them for a situation to describe it. And then solve problems both graphically and by calculation for acceleration, velocity, and displacement using SHM. If you do those practice problems I showed you before, you're going to get a good shot at that, and you have every chance of being able to totally competently demonstrate your excellent skills for 4.1 kinematics of simple harmonic motion. This concludes this section of the physics course. Go and kick some butt with it, have a bit of fun with it, ask some questions about it, and good luck with it. Take care, guys, and I'll see you later on.